Welcome to SanfordFlipMath. We are in PreCalculus. This is section 2.4, our first day on that section, and we are working from the PreCalculus book by Demana, Foley, Kennedy. It's the 5th edition, and we are working on polynomials this chapter, and this specific section deals with how to find the zeros of a polynomial when we're not talking about, just a linear or quadratic. We have very specific methods for dealing with those. And this time, now as we get into things that are more complicated, how do we handle that? That's the issue. So, many times when we're working with quadratics, we might factor, or you might use a quadratic formula, but factoring gets a little exciting when we're talking about things that are like cubic or fourth degree quartic, or etc. Factoring, reminder that factoring is basically unmultiplying. It's undistributing, unfoiling, unmultiplying in its many forms. But so is division. And we're going to spend a little bit of time talking about how to divide when we're talking about polynomials. So that's the plan for this section, and we're going to start out by working with something that should be very familiar. So for instance, let's say we were doing 525 divided by 13. Okay, so most of the time when we're doing this with long division, and I know not everybody does long division anymore, with everyday math in the lower levels, it makes it a little more interesting once we get here. And before we do this, I just noticed something about this problem that'll make it a little too easy. So I'm going to make this 535, sorry. And so what we're going to do is look at 13, and the question initially is, a lot of times we look at like the 1 and the 5, but we have to kind of look at that whole 13, and we're saying what times 13 is 53? Well, there's nothing directly times 13, no whole number, no nice number times 13 that's 53, but 52 times 13, I'm sorry, 4 times 13 is 52. So I'm going to go with 4. And 4 times 13, so we're going to multiply this. 4 times 13 is 52. And then we subtract. And so 53 minus 52 is 1. And we bring down that 5. And so then we do, what times 13 is 15? Well, that would be 1. And 1 times 13 is 13. Subtract. And so this is 2. So this is actually 41 and 2 13ths if we write it as a mixed number. Okay. Well, same kind of thing if we are going to do, let's do x to the 4th minus 3x to the 3rd plus 5x squared minus x plus 7. Okay, and let's do x minus 5. Okay, so we're going to divide these. Now, it starts out kind of similar. 13 times what is 53? It's just the difference is we're going to just look at the front part of this, and the question is what times, let's write the word times, x is x to the 4th. So we're going to write x cubed because x to the 3rd times x is x to the 4th. And so the next step after we wrote that 4 was we multiplied by 13. Now, even though over here on the x version of this, I only looked at the x times what is x to the 4th, I'm really going to multiply x to the 3rd times x and x to the 3rd times the negative 5, so minus 5x to the 3rd. And then the next step, as it was over on the numeric version of this, was to subtract. Well, I'm going to subtract here also. Now, here's my recommendation. I need to subtract this whole thing. Now, instead of writing it that way, though, this is what I'm doing. Instead of writing it that way, though, I'm going to write it where I'm just going to change the signs and add. Just like if I was doing 5 minus 3, that's the same thing as 5 plus negative 3. Well, I'm going to change the signs and add. So I'm going to make this negative and make this plus, and now I'm going to add. Now, the reason I do that this way is that people typically make mistakes, and they'll remember to subtract the x to the 4th, but then they will add just 3x cubed plus negative, negative 3x cubed plus negative 5x cubed, and they make mistakes. More likely to make mistakes if you don't distribute the minus, distribute the negative. Okay, now again, just like we brought the 5 down, we're going to bring the 5x cubed down. I'm sorry, 5x squared. Thank you for those who mentioned that at home. Okay, and then we repeat the whole process again. Okay, so we're going to look at just the x and just the 2x cubed. Okay, so what times x is 2x cubed? Well, 2x squared. 2x squared times x, 2x cubed. I'm distributing. Okay, and so times -5, so minus 10x squared. Again, I'm going to subtract, and I'm going to subtract by adding the opposite. Okay, that's what subtraction is actually defined as, is adding the opposite. So 2x cubed minus 2x cubed, or 2x cubed plus a negative, 2x cubed is 0. 5x cubed plus 10x cubed, 5x squared plus 10x squared is 15x squared. Bring down the next one. Okay, let the fun continue. So x times what is 15x squared? Well, 15x. Distribute 15x times x. 15x times a -5. Okay, again, we're going to add the opposite, so I'm going to change the signs and add. If these two guys don't add up to 0, then back up. Something went wrong. 74x, bring down the 7. Okay, we're almost there. I'm excited. I can taste it. What times x is 74x? Okay, and then we have to, again, continue to multiply, so we're distributing 74x, 74 times x. 74 times a -5, well, that's going to be minus 4, well, times 5, half of 74 is 37, so 370. Okay, and again, we need to add the opposite. Whew, good thing I got just right to the spot. Okay, so 377. Okay. All right, so at this point, I'm going to write my answer out. X cubed plus 2x squared plus 15x plus 74 plus 377 over x minus 5. Just like we did with 41 and 2/13, we actually make a fraction out of what's left. Okay. All right, so that's long division. All right, a little bit of a correction here. This was actually 375. Sorry about that. 382. 382. Okay, sorry about that. So again, 382 is that remainder. Okay. All right, that's what happens when you do things in your head on the fly sometimes. All right. Okay, just a quick little recap. You're looking at the front and the front, and you're saying what times? And then you multiply, and then you subtract. In other words, add the opposite. Okay, those are the steps, and you just repeat as necessary. Okay, so that's kind of a big deal. Okay, let's go and do it again. It's magic, I tell you. All right, so this is another division problem, and you know, division problems can be written a lot of different ways, and so that sometimes it's going to look like this. It just looks like a rational expression. And I just tell you, if it asks you to then divide or something like that, then I personally would just rewrite it. Okay, and then it becomes the same kind of problem we did before. Okay, so x to the 4th, 3x cubed. Okay, all right, so here we go. X squared times what is x to the 4th? Well, that's x squared. So x squared times x to the 4th is, I'm sorry, x squared times x squared is x to the 4th, and then x squared times 1 is 1x squared. Okay, now I got a little bit of an issue here. If you notice, these are not like terms. Well, I have two ways to handle it. One is, don't write this here, write it under here. The other way to do it is to put the missing term here. And I would recommend doing that. And every time, I know some of you are going to be mad at me, but that's okay. Every time you have a missing term, I would just write it in such a way that the missing term is accounted for. So, like for instance, this would be 0x plus 1. Don't write 1x because that would imply an x was already there. Okay, so now things are going to line up for you automatically. Okay, so I have x to the second, x to the first, no x. X to the fourth, x to the third, x to the second, x to the first, x to the 0, no x. Okay, that's what you want, whether it is as part of the dividend or the divisor. Okay, if either one, then you will really want to have all the terms present. All right, so let's try that again. X squared times what is x to the fourth? All right, so now I need to distribute. So x squared times x squared times 0x, x squared times 1. Okay, and then we're going to subtract. In other words, we're going to add the opposite. Goodbye to you. And then this is a negative 3x cubed plus a negative 0x cubed, so that's negative 3x cubed. 6 minus 1, or 6 plus a negative 1, so this is going to be 5x squared. And we'll bring down the next term. Okay, here we go again. X squared times what is negative 3x cubed? Okay, so I'm looking at those. So this is going to be minus 3x. Negative 3x times x squared is negative 3x cubed. Negative 3x times 0x, 0x squared, negative 3x times 1. Okay, and then again I'm going to subtract. So in other words, I'm going to add the opposite. So this is gone. 5x squared is minus 0, or plus a 0x squared, negative 0, whatever. That, and then these two canceled out, but remember there's still more going on here, so I'm going to say plus 0x, and I'm going to bring down the 5. There's a plus 5 there, sorry. Okay, let's do it again. So I'm looking at x squared, and I'm looking at 5x squared. Well, that's just plus 5. What times x squared is 5x squared? 5. 5 times x squared, so I'm distributing again, so I'm going times all three of these. So 5x squared, 5 times 0 is 0, and then 5 times 1 is 5. Okay, and again, I need to add the opposite, so I'm going to make all of these opposite. 5x squared minus 5x squared is 0. That's 0, and 5 plus negative 5 is 0. So this actually had 0 remainder. Okay, so the answer for this division, the quotient, is that. Okay, now, just so you know, in our book, there are some questions that ask us to leave answers that says divide f of x by d of x and write a summary statement in polynomial form. And basically the deal is this. You would take the quotient, the answer from the division, which is a function of x, times the divisor, the thing on the outside, plus the remainder, whatever the remainder is, and that should all equal to whatever your original dividend was. Okay, so that's the inside. Okay, just a quick example of what this is saying. If I do 17 divided by 3, I end up with 3 into 17 goes 5 times. I have 2 left over, 5 2/3. Changing back and forth, most of us know, the little thing where you go 3 times 5 plus 2 is the 17, and we hardly ever write it, but here's the idea. This is that dividend. This is the divisor. Yep, that didn't work, did it? Sound it out. Divisor. This would be the quotient. This is the remainder. and this is still that divisor. Okay, so the idea again is whatever the divisor is times the quotient, so quotient times divisor, plus the remainder equals whatever you were dividing into. Okay, I don't make a big deal out of this. I just want you to see what it is. So I mean, the only time you're going to see that question is in the homework. Okay, let's do another. Sorry, before we leave that one problem we just finished, I just want to make a quick note here. On that particular problem, the remainder was 0. Much like if I do 8 divided by 2, it's 4, the remainder is 0. And that's because 2 is a factor of 8. Well, if the remainder is 0, then whatever we were dividing by, that divisor, is a factor of the dividend. Okay, so to go back, the idea again is that if I do x squared plus 1 times what my quotient was, that should give me my original. So this was a way to factor this problem. Now, mind you, we already knew a potential factor. We knew about x squared plus 1 before we even started because that was part of the problem we were given. All right, well, keep that in mind. Again, it's magic. All right, we're going to do one more problem, long division, and then I'm going to sneak in the other method, and then we'll call it good. All right. So again, I'm going to buzz through this. Remember, you can pause, rewind. In fact, I would say to you, you should pause it right now, do this division, and then see if what I do matches what you do. Okay, x times what? 2x to the 4th, 2x to the 3rd. Multiply both of these. Okay, and remember what we're going to do is we're going to subtract, so in other words, add the opposite. So this is going to be a positive x cubed. Started to write a negative, but I caught myself. Bring down the next term. Okay, so now I'm going to look at x and x cubed. So x squared times x squared times 3. Okay, and then we're going to add the opposite. Goodbye to u. This is now 10x squared. Bring down the minus 3x. Okay, so again, x, so that's 10x times x. 10x times negative 3. Okay, and again, we're adding the opposite. So 27x, nice big numbers coming on now, huh? Plus 1. All right, so we're almost there. X times 27x, or x times what is 27x? So plus 27, 27x, 27 times 3, minus 81. Okay, and again, so remember this was an x minus 3. And then we need to add the opposite, so 82. Okay, so this is 2x cubed plus x squared plus 10x plus 27 plus, don't forget the plus sign, x minus 3. If that would have been a negative remainder, you could have said minus instead of plus. Okay. Well, I want to show you a shorthand division, and it only works for when you divide by x minus a number. Now, if you have something that's x plus a number, then you can think of it as x minus a negative version of that number. Same idea, okay? All right, so what happens is you put, I'm going to do the same exact problem we just did. Okay, so we divided by x minus 3. So there's this little, what I call the box. And then what you put in there is the opposite. You put in the k. So like in this case, we'd put in 3. If we were dividing by x plus 1, then the k would be a negative 1. Okay? And then you go across the top with the coefficients of your dividend. So 2, negative 5, 7, negative 3, and 1. Now, in the original version of this, in the long division version of this, what we do is we say what times, what are we multiplying by? Then we multiply or distribute as it is, and then we subtract, or in other words, add the opposite. Well, if you are dividing by something that's a plain old x up front, this coefficient always ends up being right there. Well, in the same manner, this coefficient, we just bring it down. Okay, so the first one, bring it down. Okay, then everything after that is multiply and add. Now, it's not subtract on this one because we did the opposite of whatever that k was. So instead of adding the opposite's already taken care of. And then, so what? Watch this. 2 times 3. So this 2 times this 3 is 6. Then we're going to add negative 5 plus 6 is 1. 1 times 3 is 3. And we add 10. 10 times, okay, so all we're doing is adding straight down, and then we multiply, and then we add, and then we multiply, and then we add. So again, we brought down the 2. 2 times 3 is 6. Negative 5 plus 6, we're adding, is 1. 1 times 3 is 3. 7 plus 3 is 10. 10 times 3 is 30. Add, multiply, add. Okay, so how does that help us? Okay, notice this 2 is that 2. The 1 is the coefficient here, the 10 is the coefficient here, the 27 is the coefficient here, and then the 82, remember, it was the remainder. Okay, so I usually put a little line, an extra line here, and I don't think your book does, between those two to remember that that's going to be the remainder. Okay, so this is now we divided a 4th degree divided by a 1st degree, so the answer ought to be a 3rd degree. So this is going to be 2x cubed plus 1x squared, you don't need to write that one, plus 10x plus 27, and then the remainder over whatever we divided by. It's not just 3, it's x minus 3. This is called synthetic division, and you should have seen that last year. Again, you can only use synthetic division if you are dividing by something that does not have a coefficient in front of the x, and it's got to be x to the 1st power, and so plus or minus a single number. Okay? All right, well, that was a speed version of synthetic division. We did a couple examples of long division, and we will do more in class, and then in the next lesson we will talk about how to use all of this. Thank you much.